Hello, and welcome to Random Variables. My name's Tuesday Johnson. Here's an introduction to concept with applications. Maybe. All right, let's talk about random variable. What is it? Let's start with the definition. A rule that assigns a number to each outcome of an experiment is called a random variable. So a rule that assigns a number to outcomes. So we might roll a die or some dice. X might be the number of dots facing upward. Maybe we'll toss some coins. X will be the number of heads facing upward, or the number of tails facing upward, or the number of coins that get stuck on their edge. We might select a student in math class and X is the student's numerical grade in class. Or, why is it called a random variable? We get to randomly choose what we want to measure. So X might be the length of a student's hair in centimeters, or the width of the student's right hand first knuckle of their thumb in millimeters, right? We can measure anything we want to, any randomness. We just want to be able to assign it a number. So there's two different ways we could think about random variables. And the first is discrete versus continuous. And discrete, that's like dice, right? When you roll a single die, you can get 1 through 6. When you roll 2 of them, you could get 2 through 12. That's the only values. They're discrete, they're separated. Dollar values rounded to the nearest whole dollar. Those are discrete, separated, isolated numerical values. If we used the change as well, like cents, maybe to be more continuous, right? Because one value leads right on to the next one. Heights, heat, or temperature, those are frequently thought of as continuous because one leads right on into the next. If we're rounding to the nearest whole dollar, money's not, but money could be. The other way we sort is between finite or infinite, and just like any other time that I've defined finite, it's limited or bounded. It ends, right? It ends, and infinite, it doesn't, right? So hopefully there's infinite earning potential, right? Even if it's discrete, we want that number to keep growing. Okay, let's take a look at example. So let's suppose there are 3 new color guard members on the UTEP Diamonds color guard squad. Go watch them; they're awesome, along with the band. All inclusive too. If you've ever been in color guard and you want to give it a shot, they will welcome you. Let's let X be the number of catches on the big toss of the show. Okay, so what values might X take on? I'm looking at the 3 color guard members and the number of catches on the big toss. We have the following outcomes. I use C for catch and M for a miss. So all 3 of them could catch it, which they probably did, I'm just saying. It could be a catch, catch, miss, a catch, miss, catch, a catch, miss, miss, and so on. Right? So how many, the number of catches is what we're measuring. So there are 3 catches, 2 catches, 2, 1, and so on, counting the C's each time. And from our earlier discussion of probability and counting and things like that, you already know that we have all of them listed here, right? It's either you catch or you miss. 3 times 2 times 2 times 2, 8 total outcomes. The random variable here has possible outcomes of 0, 1, 2, and 3. So X being the number of catches on the big toss. Phone. I forgot to remute it. It happens. X being the number of catches on the big toss of these 3 new guard members. Possible outcomes 0, 1, 2, and 3. Now, we can look at events specifically as well. Given any random variable X, we can consider specific outcomes. For example, in our previous toss using color guard, the UTEP Diamonds, we might be interested in, we want to know the probability that there were exactly 2 catches. Or maybe even 2 or more catches, right? X is greater than or equal to 2. All right, that's it for random variables. Thank you for listening.